Hi everyone. Today we're going to study rectangular coordinate system. In particular, we're going to study plotting of points and the quadrants. Let us define rectangular coordinate system, or sometimes called Cartesian coordinate system. The rectangular coordinate system consists of two real number lines that intersect at a right angle. This horizontal line is called the x-axis and the vertical line is called the y-axis. These two number lines define a flat surface called a plane. The intersection of these two lines is called the origin. If we look at our x-axis from the origin going to the right side, we will number this portion as positive numbers, starting from 1, 2, 3, 4, 5, so on and so forth. Also, from the origin, going to the left side of the x-axis, all numbers here are negative, starting from -1, -2, -3, -4, -5, so on and so forth. Looking now at our y-axis, from the origin going upward, all numbers are positive. So you see, this is +1, 2, 3, 4, 5, so on and so forth. From the origin going downward of the y-axis, all numbers are negative. -1, -2, -3, -4, -5, so on and so forth. The rectangular coordinate system is composed of so many points, and each point on this plane is associated with an ordered pair of real numbers xy. An ordered pair xy represents the position of a point relative to the origin. The first number here is called x-coordinate or abscissa, while the second number is called y-coordinate or ordinate. Let us learn how to plot a point on the rectangular coordinate system. Let's begin with an example. Plot the point +2 and +3. Always remember, the first number represents the x-coordinate. The second number is for the y-coordinate. Looking now at our rectangular coordinate system, let's start with the number 2, that is for the x-coordinate. We will look at our x-axis. The +2 is here. Then we will look now for the y-coordinate, and that is +3. From the origin, we go up, that is the +3 of the y-axis. And then we will get the intersection of this +2 of the x and the +3 of the y. So here is the point. Let us have more examples. Plot the points. We have here 5 points. Let's begin with the first point, 4, 0. The 4, 0 is here. This is the point. So the first number is 4, that is for the x, so that is positive. From the origin, we go 4 units to the right. Then the y-coordinate is 0, so this is now the point 4, 0. The next number is -6, 0. So let's begin with the -6. It means that is for the x-coordinate. We look at our x-axis. From the origin, we go 6 units to the left. So this is the negative 6. And our y-coordinate is 0. So this is the point, the negative 6, 0. The next is the point 0, 3. We begin with the number 0, that is for the x-coordinate. Our x-axis is here, the value 0 is here, and then the y-coordinate is 3. We go 3 units up. So this is now the point 0, 3. The next point is negative 2, 6. Let's start with the negative 2. It means from the origin, we go 2 units to the left. This is the negative 2. And then the y-coordinate is positive 6. From the origin, we go 6 units upward. And then we will take the intersection of the negative 2 from the x and the positive 6 from the y. And here is the point. The last ordered pair here is negative 4, negative 6. Let's begin with the x-coordinate. Negative 4 means on the x-axis, from the origin, we go 4 units to the left. Here is the negative 4. And then for the y-coordinate, it is negative 6. From the origin, we go downward 6 units. So this is now the negative 6. Then we take the intersection of the negative 4 and the negative 6 here, and here is the point. Let's proceed with the quadrants. The rectangular coordinate system is actually divided into 4 quadrants. This is the first quadrant. In the first quadrant, all the points here have ordered pair, that is positive x coordinate and positive y coordinate. On the left side of the first quadrant is the second quadrant. All the points that you will see on the second quadrant have ordered pairs that have negative x coordinate and positive y coordinate. Down the second quadrant is the third quadrant. In the third quadrant, you will see the points that have ordered pairs having negative x coordinate and negative y coordinate. On the right side of the quadrant 3 is the quadrant 4. In the quadrant 4, all points that you will see here have ordered pairs with positive x coordinate and negative y coordinate. Let us state the quadrant in which the given point lies. I have here 4 points. The first point is 5, 7. We can see that the x is positive and y is also positive. In this case, the point 5, 7 lies quadrant 1. Second ordered pair, the negative 3, 2. We can see that the x coordinate is negative and the y coordinate is positive. In this case, this point lies in second quadrant. For the third ordered pair, we have negative 12, negative 15. The first number, the x coordinate, is negative, while the second number, the y coordinate, is negative 15. This ordered pair lies in the third quadrant. For the ordered pair 7, negative 8, we can see that the first number, the x coordinate, is 7 and the y coordinate is negative 8. It means this ordered pair lies in the fourth quadrant. Hi everyone. Today we're going to study distance between 2 points. Let us define the distance between 2 points. The distance between 2 points is the length of the straight line between those 2 points. I have here 2 points, and let us name these 2 points. The first point is P sub 1 with coordinates x sub 1 and y sub 1. The other point is P sub 2 with the ordered pair x sub 2, y sub 2. Let us connect these 2 points, and the distance between these 2 points is the length of this straight line. Let us draw a horizontal line segment that will pass through P sub 1, and it's here. Also, let us drop a vertical line segment that will pass through P sub 2. By doing this, we will form a right triangle here. Let us name the sides of this right triangle. In the rectangular coordinate system, this side here can be named as x sub 2 minus x sub 1. Also, the side here, considering the ordered pair of the P1 and P2, this side is y sub 2 minus y sub 1. By the triangle here, the D corresponds to the hypotenuse of the right triangle. So by the Pythagorean theorem, the square of the hypotenuse, which is the D, here we write D square, is equal to the sum of the squares of the two other sides. Let us write first this side, and we square this. So we write here x sub 2 minus x sub 1, and it is squared, plus the side here is the y sub 2 minus y sub 1. The quantity is squared. And to make this D without the square, we will take the square root of both sides. And this is now what we call the distance formula between 2 points. Let us have example 1. Calculate the distance between the points -3, -1, and -2, 4. Let us assign the first point to be the P sub 1 with the ordered pair x sub 1, y sub 1, and the second point to be P sub 2 with the ordered pair x sub 2, y sub 2. Then our distance formula is written here. Let us start substituting the values for our distance formula. Our x sub 2 is -2, then minus the x sub 1, which is -3. This group is now squared, and then plus the y sub 2 is +4, then minus y sub 1 is -1. This group is squared. Then let us simplify further. Let us remove the grouping symbol for its x and y's. So the -2 here is without the parenthesis. Then the minus and the negative becomes +3. The square is there. Then plus. The parenthesis of 4 is removed here. The minus and the -1 becomes +1. And again, we don't forget to write the square. Then we simplify further on the next step. The -2 plus 3 is now +1. And we copy the power 2, then plus 4 plus 1 is 5 square. Then we simplify the square now. 1 square is 1 plus the 5 square is 25. So 1 plus 25 is 26. So the distance is equal to the square root of 26. We put the word units, and this is our final answer. There is a question here. What will happen if the p sub 1 and p sub 2 are interchanged? It means, can we use the first point to be p sub 2 and the second point to be p sub 1? Let us solve that one. So I put here the first point to be the p sub 2 and the second point here to be p sub 1. Let us solve using our distance formula. Let us substitute the values. The x sub 2 is the negative 3, then minus x sub 1 is negative 2. Of course, we write the square, then plus y sub 2 is negative 1, then minus y sub 1 is positive 4. Then let us simplify this equation. We remove the grouping symbol from negative 3. It is now written here. The minus and the negative 2 becomes plus 2. We write the square, then plus. We remove the grouping symbol from negative 1. It is now negative 1 here. Then minus of this positive 4. So we remove the grouping symbol. And the square is copied. Then we simplify further. The negative 3 plus 2 becomes negative 1. Then the square is there. Plus negative 1 minus 4 is negative 5. The power 2 is copied. And then we simplify on the next step. The square of negative 1 is positive 1. The square of negative 5 is positive 25. So 1 plus 25 is 26. So our distance is equal to the square root of 26. This is our final answer. Our answer to the question is, when we use the first point to be p sub 1 and the second point to be p sub 2, or vice versa, the derived distance will be the same. Let's have example 2. Calculate the distance between negative 5, 3 and negative 9, 6. Let us assign the points. Let this be the p sub 1 and the other point to be the p sub 2. Our distance formula is here now. Let us substitute the values. Our x sub 2 is negative 9 minus x sub 1 is negative 5. We put the square and then plus. The y sub 2 is positive 6 minus the y sub 1 is positive 3. And we put the power 2. Then we simplify further. We remove the grouping symbol of negative 9. It's now without the parenthesis here. The minus and the negative 5 becomes plus 5. We copy the square. Then plus. We remove the parenthesis for the 6 and for the 3. The minus sign is simply copied here. Then we simplify further. The negative 9 plus 5 is negative 4. And then that is squared plus 6 minus 3 is 3. We copy the power 2. Then we simplify again. The square of negative 4 is positive 16 plus the square of 3 is 9. 16 plus 9 is 25. And we can simplify the square root of 25 to be 5. And our answer for the distance is 5 units. Hi everyone. Today we're going to study slope of a straight line. Let us define the slope of a straight line. The slope of a straight line is the ratio of the vertical change to the horizontal change of the line. The slope is symbolized by letter M, and this is equal to the ratio of vertical change over horizontal change. To simplify, we can write the vertical change to be rise and the horizontal change to be run. So the slope is equal to rise over run. Let us have an example. Find the slope of the given line. On this line, there are 2 points, the 1, 1 and the 5, negative 2. So the formula of slope is m equals rise over run. From the point 1, 1, we are going to rise, but this is going down, so we put negative 3. We are going down 3 units and then 4 units going to the right till we reach the point 5, negative 2. So we have here the ratio, the negative 3 over 4. This is the slope. There are 4 geometric cases for slope value. Case 1 is positive slope. The symbol is here. M is greater than 0. Take note that we're going to read the graph from left to right. So the line is here. It's like going upward, but we can say that this is inclined to the right. The case 2 is when we have negative slope. Our symbol is M is less than 0. Again, we are going to read the graph from left to right. You see the line? It is like going down. Or we can describe this line to be inclined to the left. The case 3 is when we have 0 slope, or we say M, the slope, equals 0. In this case, the line is horizontal, or we can say that all horizontal lines have 0 slope. The case 4 is undefined slope. The M is undefined. The lines with undefined slope are the vertical lines. Also, all vertical lines have slope that is undefined. Let us study now the slope of the line joining 2 points. Given any 2 points P sub 1 with ordered pair x sub 1, y sub 1, and the second point P sub 2 with ordered pair x sub 2, y sub 2, the slope is given by the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Let us have example 1. Find the slope of the line passing through negative 3, negative 5 and positive 2, positive 1. Let us assign the first point to be p sub 1, the second point to be p sub 2. Then we will write the formula of the slope here. Let us collect the values from the p sub 1 and p sub 2 respectively. The y sub 2 is equal to positive 1. Then minus the y sub 1 is negative 5. All over the x sub 2 is positive 2. Minus x sub 1 is negative 3. Then we will simplify the numerator and the denominator. 1 minus a negative 5 becomes positive 6. All over 2 minus a negative 3 is positive 5. So this is now our slope. We know that since the slope is positive, the line is inclined to the right. We have one question here, that is, what about if the p sub 1 and p sub 2 are interchanged? It means, what if we take the first point to be the p sub 2 and the second point to be the p sub 1? Let us solve this. Let us write the formula of the slope. Then let us collect the corresponding numbers. Our y sub 2 is negative 5. Minus the y sub 1 is positive 1. All over x sub 2 is negative 3. Then minus x sub 1 is positive 2. Then let us simplify the numerator and denominator. Negative 5 minus 1 equals negative 6. Negative 3 minus 2 is negative 5. When we divide negative by a negative, the answer is positive. So our slope here is positive 6 over 5. And we can see that the answer here is the same with our answer in the first method. For our conclusion, we can say that given any 2 points here, we can pick any point to be the p sub 2 and the other point to be p sub 1, or vice versa, and we will have the same answer. Let us have example 2. Find the slope of the line passing through negative 1, 4 and 6, 4. Let us assign the p sub 1 and the p sub 2 respectively. Then we write the slope formula. We collect now the values. Y sub 2 is positive 4 minus y sub 1 is 4 all over x sub 2 is positive 6 minus x sub 1 is negative 1. Then let us simplify our fraction. 4 minus 4 equals 0. 6 minus negative 1 is 7. So this is 0 divided by 7 equals 0. Since the slope is 0, we know that the line is horizontal. Let us have this example 3. Find the value of b if the slope of the line passing through negative 2, 3 and the point for b is 12. Let us assign the p sub 1 and p sub 2 respectively. Then we will write our slope formula. Let us now substitute the corresponding values. For the m, substitute the value 12. equals the y sub 2 is the b minus y sub 1 is positive 3 all over x sub 2 is positive 4, then minus x sub 1 is negative 2. Then let us simplify our denominator. 4 minus a negative 2 is equal to positive 6. In the numerator, we will just remove the grouping symbol for each number. So the b is now without the parentheses minus 3. From this point, we're going to cross multiply 6 to the 12. Multiply 12 by 6, we have 72 equals b minus 3. Let us isolate the b. We are going to add positive 3 to both sides of the equation so that the negative 3 here will be cancelled. On the left side will be 72 plus 3 equals 75, and this is equal to b. And from here, we can just simply interchange the position of the b goes to the left side, 75 on the right side. So the value of b equals 75. This is our final answer. Let us have more sample problems. Problem 1. Plot the following points. We have here 4 points. Let's begin with point A. We draw our x and y coordinate system. Then point A is negative 8 for the x, 3 for the y. This is the point. Then we write the coordinate near that point. Point B, negative 4 for the x, 6 for the y. And the point is here. We write the coordinates near that point. Then point C, 0, negative 6. 0 is for the x, negative 6 for the y. And the point is here. We write the coordinates near that point. Then point D, 6, 5. 6 for the x, 5 for the y. And the point is here. We write the coordinates near that point. Problem 2. Find the distance between the two given points. We have here A and B. Let's begin with A. The points are negative 6, negative 8, and 0, 0, or the origin. We have the big formula for the distance, and it's here. Now let us substitute the values. We assume that the first point is the P sub 1 with coordinates x sub 1, y sub 1. And the second point is the P sub 2 with coordinates x sub 2, y sub 2. Substituting the values now, we have the square root of x sub 2 is 0 minus x sub 1, that is negative 6. Now with the power 2, then plus the y sub 2 is 0 minus y sub 1, that is negative 8. Then the power 2 again. Let us simplify 0 minus negative 6. That will be positive 6 with the power 2 plus 0 minus negative 8. That becomes positive 8 with the power 2. Of course, we wrote this big square root. Simplifying 6 squared is 36 plus 8 squared is 64. And the sum 36 plus 64 is 100. Now we simplify square root of 100. That will be the D. The value is 10. We now write this answer below the problem A. We go to B. The points are 0, 1 and 1, 0. The first point we consider to be the P sub 1 with x sub 1, y sub 1. And the second point is the P sub 2 with coordinates x sub 2, y sub 2. Let us now substitute the values in our formula. X sub 2 is 1 minus x sub 1, that is 0, now with power 2, plus y sub 2, that is 0, minus y sub 1, that is 1, with the power 2. Let us simplify further. 1 minus 0 is simply 1 with power 2, plus the 0 minus 1 is negative 1 with the power 2. The square of 1 is 1, plus the square of negative 1 is positive 1. 1 plus 1 is 2. Of course, we write the square root. This is the distance. Then we write the answer below the problem B. Problem 3. Find the slope between the two given points. Let's begin with A. The points are 2, negative 3, and negative 3, 2. We know the formula. M here is the slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For the two given points here, we assume the first point to be the P sub 1 with coordinates x sub 1, y sub 1. And the second point P sub 2 with coordinates x sub 2, y sub 2. Let us now substitute the corresponding values. In the numerator, y sub 2 is 2 minus y sub 1, that is negative 3, all over the x sub 2 is negative 3 minus x sub 1 is 2. Then we simplify. In the numerator, 2 minus negative 3. Negative and negative becomes positive. So 2 plus 3 becomes 5 over negative 3 minus 2 is negative 5. Then the quotient 5 divided by negative 5 is negative 1. This is the slope for the 2 points. We copy the answer below problem A. We go to problem B. The points are negative 1, negative 6, and 3, 2. We assume the first point to be the P sub 1 with coordinates x sub 1, y sub 1. For the second point, that is the P sub 2 with coordinates x sub 2, y sub 2. Let us now substitute the values in the formula. So y sub 2, that is 2, minus the y sub 1. We write here negative 6, all over x sub 2, that is 3, minus x sub 1, that is negative 1. Let us now simplify further. In the numerator, 2 minus negative 6. So negative and negative becomes positive. So here, 2 plus 6. We get 8 over 3 minus the negative 1. That means 3 plus 1. So we get 4. Then 8 divided by 4 is 2. This is the M. This is the slope. We copy the answer below problem B.